Greetings. In part 3 of testing AI image-to-video physics, I'll examine a domino setup. This experiment involves a line of dominoes positioned so that tipping one causes the others to fall sequentially. Since AI models are trained on videos, they should have been exposed to domino sequences and thus be capable of generating fairly accurate representations of this chain reaction. For this experiment, I'll test 5 AI image-to-video generators: Kling, Luma, Pixverse, Runway Gen 3, and Haiper. Haiper replaces Pika, which had been generating for 2 days with no end in sight, and so I haven't been able to include in this video. Notably, Haiper allows users to set intermediate and final keyframes in addition to the initial frame. I've tested Haiper both with a single starting frame and with intermediate and end frames. Kling has a new feature called Motion Brush. This allows you to specify how objects should move in the scene. As with Haiper, I've provided normal and motion brush examples. In this video, I've simplified the rating system from previous experiments to make it more meaningful and representative. Each category will still be scored out of 5. The new ratings are as follows: gravity, accuracy of object movement under gravitational influence; fluid dynamics, realism of fluid behavior; rotation, precision of object rotation; light and shadows, accuracy and consistency of scene lighting and object shadows; collision response, quality of interactions between moving objects and the environment; frame-to-frame continuity, consistency of the scene throughout the video; preservation of details, maintenance of image sharpness over time; and physics-based predictability, alignment of the final result with expectations based on the initial scene. In the following generations, each AI was given the initial frame and the prompt. One domino at the upper right is toppling over and should cause the others to fall in turn. First up, we have Haiper. In this example, I've just given it an initial frame to work with. While there is plenty of movement, none of it is physics-based. The dominoes morph, some like Tetris-like blocks. I give the following scores. Gravity, 1. Isaac Newton seems to be mostly ignored, and some of the dominoes are floating in mid-air. Rotation, 1. The blocks should rotate as they fall, but here the rotations are entirely random. I suppose at the very least they are rotating. Light and shadows, 5. The lighting is consistent and the shadows are accurately generated, both against the ground and between the dominoes. Collision response, 2. The AI is aware of when dominoes hit each other, but in this case they tend to merge. Frame-to-frame continuity, 5. The camera does not move and the scene remains consistent. Preservation of details, 5. If the morphing is ignored, the edges of the dominoes remain sharp. Physics-based predictability, 0. This is more likely to happen in a dream rather than in a real setup anywhere in this universe. This gives an average score of 2.71 for Haiper. Staying with Haiper, in this example I gave it these 3 frames. The results are better. The scores are gravity, 3. Gravity is again mostly ignored between the 3 keyframes. Rotation, 4. The blocks do rotate for the most part correctly between frames. Light and shadows, 5. The lighting is consistent and the shadows are accurately generated. Collision response, 2. The AI is aware of when dominoes hit each other, but in this case they tend to merge. Frame-to-frame continuity, 5. The camera does not move and the scene remains consistent. Preservation of details, 5. If the morphing is ignored, the edges of the dominoes remain sharp. Physics-based predictability, 5. But in this case only because I have provided the end frame. The average score for Haiper with keyframes is 4.14. Next is Kling. Here I have just given it an initial frame to work with. The dominoes don't fall but magically move neatly into a straight line. Then a mysterious hand comes down and plucks one up. Bizarre. I give scores of gravity 1. There's not much evidence of gravity other than the dominoes maintaining their positions on the ground. Rotation 0. The dominoes should rotate, but they don't. Light and shadows 5. The lighting is consistent and the shadows are accurately generated. Collision response 2. The AI is aware of when dominoes hit each other, but in this case they tend to merge. Frame-to-frame continuity 5. The camera does not move and the scene remains consistent. Preservation of details 5. If the morphing is ignored, the edges of the dominoes remain sharp. Physics-based predictability 0. The dominoes end up in a totally wrong configuration. The average score for Kling is 2.57. Next, I tried Kling with motion brush. Here I have indicated the general motion that the first domino should take. Unfortunately, this is not translated to a rotation and proper interaction with the remaining dominoes. The scores are gravity 1. Again, there's not much evidence of gravity other than the dominoes maintaining their positions on the ground. Rotation 0. The dominoes should rotate, but they don't. Light and shadows 5. The lighting is consistent and the shadows are accurately generated. Collision response 3. The AI is aware of when dominoes hit each other and there is no merging. Frame-to-frame continuity 5. The camera does not move and scene remains consistent. Preservation of details 5. The edges and dots of the dominoes remain sharp. Physics-based predictability 0. Again, the dominoes end up in a totally wrong configuration. The average score for Kling with motion brush is 2.71. Here we have Luma. The original domino configuration remains unchanged. The camera moves to the left and we have some spurious domino-like pieces appearing. The scores are gravity 1. There's no evidence of gravity in the original setup, but the spurious extra dominoes tend to float downwards. Rotation 0. The dominoes should rotate, but they do nothing at all. Light and shadows 5. The lighting is consistent and the shadows are accurately generated. Collision response 0. No collisions occur. Frame-to-frame continuity 5. The scene remains consistent. Preservation of details 5. The edges and dots of the dominoes remain sharp. Physics-based predictability 0. The dominoes don't move at all. The average score for Luma is 2.29. Now for Pixverse. The scene is perhaps the most strange of all the generations. The dominoes look like they are being hit by shrapnel before a blue wash comes in from the left and the camera starts to somersault. The scores are gravity 2. The bits of dominoes fall towards the ground, although it's hard to know what is really going on. Rotation 0. The dominoes should rotate, but they tend to just morph. Light and shadows 3. The lighting and shadows do some strange things. Collision response 1. Some of the dominoes pass through others. Frame-to-frame continuity 5. Despite the strangeness, the scene remains consistent across frames. Preservation of details 3. The dominoes lose their sharpness and the scene becomes blurry. Physics-based predictability 0. The dominoes end up not even being dominoes. The average score for Pixverse is 2.0. Lastly, we have Runway Gen 3 Alpha Turbo. Another strange scene. The original setup stays almost the same, apart from some slight morphing and position changes. Strange dominoes fall from the sky and neatly line up to the right. Then some domino bits fall down and magically vanish. The scores are as follows. Gravity, 5. Things fall from the sky and hit the ground. Rotation, 0. The dominoes should rotate, but they don't. Light and shadows, 5. The lighting is consistent and the shadows are accurately generated both on the ground and on the objects. The ground gets lighter as the camera pans right to where the light source is. Collision response, 1. The AI is aware of when dominoes hit each other, but in the one case that it happens, the dominoes merge. Frame-to-frame continuity, 5. The camera moves, but the scene remains consistent. Preservation of details, 5. The edges and dots of the dominoes remain sharp. Physics-based predictability, 0. The dominoes barely change their initial configuration. The average score for Runway is 3.0. In summary, the results show that while these AI systems excel in certain areas like maintaining consistent lighting and preserving visual details, they struggle significantly with accurately simulating physics-based interactions and predictable object behavior. I am somewhat surprised that none of them managed to generate a video which was even partly realistic, given that they must have been trained on millions of videos, which surely must have had at least 1 or 2 examples of a domino fall sequence. Common issues include dominoes floating, merging, or morphing instead of falling naturally, lack of proper rotation, and unpredictable or physically impossible behaviors. While some generators performed better in specific aspects, such as Haiper when given multiple keyframes, all of them failed to create a physically accurate representation of domino physics, highlighting the current limitations of AI in simulating complex physical interactions. The highest scoring of the AIs was Haiper with keyframes at 4.14. In second place was Runway with 3.0. The lowest scoring was Pixverse with 2.0. Thanks for watching. I'll see you next time.